All right, so welcome everybody to our January 2023 water monitor meeting. I'm Eric Admin, and I'm just going to maybe go around and call on folks that I can see in the screen, and maybe you can just give a brief introduction to yourself and your connection to water monitoring. So on my screen, I'm going to start with Glenn Heyman.
Yeah, my name is Glenn Heyman. I'm a retired hydrogeologist. I spent my career working in hazardous waste, so I'm familiar with doing a lot of groundwater monitoring. Currently, I'm got a site set up on Bear Creek and on Evans Creek. I've got a couple of others registered that I need to start monitoring soon. What else? That's enough. Oh, and this is Linda Sue. She's hiding over here off to the side. She's my partner in crime.
She monitors.
I offered to put her in the picture, but she refused to move over.
And you have one more water monitor there too, right?
I don't think Annika's going to be involved anymore.
Okay.
She moved down to Portland. She's got a job down there. She moved down there in September. So unlikely we will see much of her.
Okay. All right. Well, at least we got two in the household.
Yeah.
Okay. How about Kate?
I'm Kate. I was trained as a water monitor last year. I've been undergoing a long apprenticeship with Lori on Bear Creek. So I just keep my hand in and aspire to do more.
Awesome. Paula.
Oh, you're muted, Paula.
Yeah. Okay. My name is Paula Goldberg. I'm retired. I was a probation officer for like most of my life. I never had any experience in dealing with water monitoring, but I know that it's something that's really important for the future of our planet. So I think it was about a year and a half ago that I took the class, and I've been monitoring with Jim Freese, and recently a new guy. So now there's three of us doing the monitoring at the same sites. Anurag, and I don't know if Anurag's attending here or not tonight. And it's interesting, but I do rely very heavily on Jim, since he's really like been around, I think, forever with this. So, and he's really good. He's really can learn a lot from that man.
Awesome. Well, thanks, Paula. How about Alan?
Hey, how are you? I'm Alan. I've been doing monitoring that now for a year and a half, I think, something like that. I took a class here in Kirkland, and I have a couple of sites. I like to do this every month, and well, it's a lot of fun.
That's awesome. What I love is that Alan always sends me copies of his monitoring reports after he monitors. So he volunteers in Kirkland. So he sends a copy to Kirkland and a copy to me. And also another neat thing about Alan is that through his workplace matching, the hours that he's donated his time water monitoring has translated into dollars coming back to Sno-King Watershed Council. So big thanks to Alan for working through that. So if anyone has employers that match volunteer time or money, that's something you can do. All right, how about Nicole?
Hello. Yes, so I actually have been introduced to the Sno-King Watershed Council through an internship I did with Whale Scout, and that's where Eric kind of did his first training with the interns, and so it was a really great experience, and I've enjoyed sort of staying with that partnership. I continue to volunteer a lot with Whale Scout, and actually did a summer internship where I was more like a paid position as an intern coordinator, and ended up running back into Eric again after a little hiatus of being busy with school. I'm also a UW Bothell student, and actually tonight have some fun, interesting information for you guys that hopefully you'll enjoy. So yeah, that's a little bit about me.
Thanks, Nicole. Yeah, she did a research project for us, and she's going to talk about that this evening about some new monitoring that I think we're going to add to our suite. How about Jeff Staley?
Hi, Jeff Staley. I've been monitoring on Little Swamp Creek in Bothell and Swamp Creek in Kenmore for, I don't know how long, Eric, at least 6 years, maybe more, I don't know.
Maybe more.
Maybe more, pretty much from the beginning, from the get-go. So retired.
Jeff's in our infamous first class alumni picture that I always show. How about Debbie Nelson?
Hi, I'm sure everyone's like, who's this person? Because I have been MIA for so long. I mean, water quality is so important to me. I worked for the county and I did all sorts of water issue things. But then between COVID and I have a funky coffee house, I've had like no employees, or I had for years. And then out of the blue, my poor hubby got hit with just a string of like one cancer, various health issues, and I was just overwhelmed. And then I seem to have a habit of my partners move away. If you want to get a good job, be my partner down here. I'm down in Renton, and I was starting to test on Cedar, and there's also May Creek, and there's so many opportunities down here. But every time I have a partner, they move away somewhere and get a great job. So if you want that to happen, come be my partner. Eric, find me a Renton partner.
All right, we'll do that.
Hope to be back now. Yeah.
Okay, how about Stacy Admin?
Hi. Oops, I can hear myself in the other room. I'm Stacy and I monitor on Little Swamp Creek in our yard with Eric. And we used to do Swamp Creek too, and maybe we'll get a spot back there later. There you go.
All right, and I see Mark Phillips. Glad to see you here.
Yeah, hello. Glad to be here. So I'm a former council person in Lake Forest Park, and as such, I was assigned to the Raya 8 Salmon Recovery Council and worked on salmon recovery, funding salmon recovery projects. And have been monitoring for 20 plus years, and whenever the Water Watchers started, is the last 10 years of that, I guess, in our streams here in Lake Forest Park, McAleer Creek and Lion Creek.
You know, Lake Forest Park Streamkeepers is a very long-running community-based water monitoring program. And Mark is sort of handing the reins over to Brian Saunders, who I see here as well. Brian, you want to introduce yourself?
Oh, yeah. Well, thank you. Yeah, I'm Brian Saunders, and Mark has been very good at my tutoring for me to take over. But I just wanted to add what Mark said. You know, we've been very active at Lake Forest Park. We've got some 15 or so recruits, and we've recently added nutrient analysis. I found an old Hawk meter from my college that I teach at, and it seems to be doing a fairly decent job. And so we're measuring the nitrates and phosphorus, and we even added in the turbulent discharge as one of our quarterly monitoring systems. So yeah, we're doing a lot of great things at Lake Forest Park. It's fun.
Yeah, so you guys also do BIBI, and
We do
that for a long time, which is quantitative analysis of benthic macroinvertebrates or stream bugs. So
yeah, now just a real quick thing on that. We did a real interesting thing last year. We had some spraying on one of our creeks, so we monitored just downstream from it, and then we monitored again this year to see if what happened, if there was any effect, and there really did seem to have a negative effect from the spraying, but the stream seemed to recover pretty well. So that was actually good and bad news all rolled into one.
Interesting.
Yeah.
Cool. Thanks, Brian. I see Anna Bachman.
Hi. So yes, I'm with Puget Soundkeeper Alliance. I actually have a new title now. I'm the Clean Water Program Director, and running all the stewardship activities, our pollution hotline, and our Lost River and Creeks project. And we are focusing this year on sampling in Springbrook Creek watershed in Kent and Renton, but we're only doing quarterly monitoring there. So we've actually added 2 new streams. One will be Mill Creek in Auburn, And the other, and I mentioned, I believe Debbie was looking for people who are interested in monitoring May Creek. We're going to be doing May Creek in Renton. And our next time going out, I was just checking that, is Saturday or Sunday, the 18th or 19th, and we'll be doing May Creek, doing 6 sites in May Creek. So if you want to talk to me about that, please do it in the chat.
And we've partnered with Anna and Puget Soundkeeper, and then we also partner with another group called Unleash the Brilliance. It's kind of a youth leadership group down there.
Yes.
And
Should have mentioned that. Yeah.
They use some of our same techniques, but they also use I think a YSI meter for electronic monitoring of some of the variables that we monitor, just because for a bunch of youth and a bunch of sites, it works better and it's a little more accurate. Okay, how about, I'm going to save you for last, Cameron, because I'm going to let you talk for longer. How about Jeannie Dorn?
Yeah, thank you, Eric, so much for inviting me tonight. And I'm so impressed with all the citizen science that you all are doing. Keep it up. It is wonderful. So who I am in my working life, I work for King County Stormwater Services, and the programs I help manage actually look for pollution getting into our stormwater system. Well, our stormwater system flows to creeks and Puget Sound. And so you'll hear some more details about how we look for pollution from my colleague Cameron. But we work all throughout unincorporated King County, and we've got thousands of sites we've tested over the years. And Eric, I really miss the potlucks. I've been to a couple Sno-King Watershed Council potlucks, and I would say they were some of the highlights of my career at King County. So thank you all.
Wait,
To do
Eric,
another
if you're
one of
going
those
to
this
have a
summer.
potluck, would you like me to bring smoked brisket or pulled pork?
We'll plan it. We'll plan it.
Both.
Okay.
All right, I see Emery.
Yeah, hi. I got trained last fall, but I haven't been able to get out yet. I've been pretty much out of town since then, so I'm hoping to reconnect and go out in Seattle and do some monitoring soon.
Emery, are you going to join the Carkeek Park group?
Yeah, I mean, I could go to Carkeek or Thorn Creek. I mean, whatever would be most useful. I mean, I'm in Queen Anne, so I guess anything is good, really.
Could even go to Renton, maybe.
Or to Renton. Yeah. And maybe I'll take this little one with me. Not in the water, but gonna get her interested too.
She could help out.
Yeah.
Awesome. Thanks, Emery. Okay, I see Kelly. I don't hear Kelly. Oh, there's Kelly. Well, we're not getting sound from Kelly. Kelly, you can chime in if you got sound, or we can come back to you, or maybe we just don't have sound from you. All right, how about I'm going to move on to Patricia Wangan.
Hello. I live between Little Bear Creek and North Creek, and then there's the Sammamish River along there. And I started getting my training in around 2011, or not 11, 17, I think, maybe it was. And I've considered myself just helping out wherever I can, and had a lot of fun doing that, and really, really enjoyed just being by the water and doing something that was important to do. The water is so important, and I'm still interested to do it. I'm doing some work with Whale Scout, and just kind of taking it easy, getting back from the pandemic. And this kind of well, I just want to hang in there. I don't want to quit, but I'm not really active either. So here I am saying, okay, what should I do next? Not sure. So just put up with me hanging in there and being around once in a while.
We can
Thank
certainly
you.
do that, and we can invite you to our next refresher training.
Yeah, I will probably go, and who knows what'll happen from there.
Awesome. Okay, I see Stacy Douglas.
Mute. Hello. Can you hear me?
Yep.
Yep. Let's see. I have done training probably 2 years ago and then a refresher training last year. And I'm up in Snohomish and I got involved. I don't know, I just heard about it. And so I heard the Snohomish High School students really did a really nice job of doing some water monitoring on Blackman's Lake, which we're having issues with. Since then, the city, from their report, the city has conducted and actually hired a company to really come in and focus on Blackman's Lake. It's an issue. We've had people walking their dogs and the dogs drinking the water and dying. So it's very toxic. But right now, I'm in the process of ordering new agents for our 2 kits that I borrowed from the high school students. They don't have any high school students at the moment who are interested, but we're hoping they will. So we're just kind of trying to get up and going. And once we do, then my focus would be the Pilchuck River. So there's a lot going on in the Pilchuck. So we have some companies who do concrete recycling and different things along the Pilchuck. And if you go to Department of Ecology, they have been pinged with fines for pollution. So we're going to check that out.
That might be an interesting case where, usually our hardness and alkalinity tests aren't that exciting, but it would be interesting to do an upstream and downstream on that variable and see if anything shows up relative to the concrete.
Yes. Yes. So that's where we're at.
Thanks, Stacy. And speaking of
welcome.
training, our PowerPoint slides feature a nice picture of you at training, so you'll get to see yourself in a slide.
Oh, well, that's great. Thanks, Eric.
Okay, how about David Bain? Well, I see David there, but
Oh, he has in the comments, it says that he'll only be in listen mode tonight.
Yeah, knowing David. So David's one of our kind of founding fathers of this program, and he's a orca-biologist, and he also has a tendency to sign up for about 3 meetings at once. So he's probably listening to like 3 meetings at one time. Okay, Haley.
Hi, everyone. I'm Haley. I was trained about last fall. Eric kind of helped us set up a program on Carkeek Park. So I've been helping to oversee that, and we've been running for about 5 months now.
Yeah, so Haley is a graduate student, and I'm not sure what your specialty area is, but she's the coordinator of the program now, which we trained, I think, 12. We actually trained 13 people, and I think Emery is one who hasn't joined you yet, but trained all those people last fall associated with the Carkeek Watershed Community Action Project. And it sounds like you're out there monitoring a couple times a month, maybe?
Yeah, once every week, like around 8 sites a month.
That's awesome. Well, thanks,
Yeah.
Haley. Okay, I see somebody with a phone number. I don't know who the name is. It ends in 4489. If they want to say hello, they'd be welcome to. Okay, I don't know who it is, but that's fine. All right, Cameron, how about if I think we've gone around and introduced everybody. How about Cameron, do you want to introduce yourself? And then I thought you might just share a little bit about what you do, what King County does, and how you might occasionally interface with community water monitoring efforts.
Sure. Thank you. Yeah, my name is Cameron. I work for King County, and I didn't really prepare anything because I didn't know how much you would want or if you'd put the spotlight on me or whatever, but I'll just kind of ad lib here a little bit. I work for Stormwater Services, which is sort of I would call it like a drainage utility or a surface water drainage utility for unincorporated King County. We are housed within the Department of Natural Resources. And I'm sure many of you know that King County Department of Natural Resources does all sorts of water monitoring work around the county. I actually saw on the Sno-King Watershed Council's website some links that you have to the water quality monitoring data from our monthly streams program. That's linked there. You also have a link to the Puget Sound Benthos website. And I don't know that we do here in our section, the stormwater section, I don't know that we do monitoring per se in terms of going to stream sites monthly, looking for trends for various parameters. That's not so much what we do, and I'll get into some details here. But really, like I said, we're a utility. You know, we own stormwater drainage ponds and vaults, underground vaults, both publicly owned and privately owned. We build them, we inspect them and maintain them. And we have various programs related to water quality. And a lot of this is actually required, legally required programs mandated by the Department of Ecology. It's all because of the Clean Water Act and the National Pollution Discharge Elimination System, to get into some sort of bureaucratic jargon there. One program we have, for instance, is we have a water quality complaint hotline. We've actually had a water quality complaint hotline for decades, long before it was actually required. King County has always tried to be progressive in these matters, but yeah, now that's sort of, you know, all jurisdictions are supposed to have a water quality complaint hotline. And that's actually why I'm here, because we received a complaint about foam. Oh boy, there goes. I'm in a room that the lights are about to shut off, but I'm going to keep talking and turn the lights on. But basically, we had a complaint come in a couple weeks ago about foam on Bear Creek, and it wasn't clear who made the complaint other than someone from the Sno-King Watershed Council. So that's how I got a hold of Eric. And
I think they missed that part when you walked away. So what he was relaying is the fact that he got a semi-anonymous complaint about foam in Bear Creek. And so I got this phone call from him saying, hey, this is Cameron from King County. And I got referred by the Department of Ecology. Someone called and said they're with the Sno-King Watershed Council. They were reporting foam. And I was like, yes.
Yeah, I mean, that's great, because we have, you know, there's myself, Jeannie, that's on the call, and really only a couple of other people that respond to these sorts of complaints. And when you think about how big King County is, it's a lot of geographic area. I'm actually surprised, just being on this phone call, how many people are involved in the geographic extent. I really thought this was something that was like North King County, South Snohomish County, but it sounds like it's all over. So that's great. So yeah, if we also visit businesses and make sure that businesses are doing what they can to prevent pollution of runoff from their business properties. And we also have some special programs that are meant to address bacterial pollution in certain water bodies. You know, there's a lot of the water bodies in King County are impaired according to the state's water quality standards. You know, there's dissolved oxygen impairments, and there's temperature impairments, and there's pH impairments, meaning that the streams aren't meeting the water quality standards set by the state of Washington. But when it comes to our work, it's really the fecal bacteria standards that are driving a lot of our work, because the state sees that the stormwater system is responsible for delivering a lot of fecal bacteria into the streams. We own the stormwater system, and so we're on the hook to try to reduce the fecal bacteria entering these streams via our stormwater system. So I hope you're you're not going cross-eyed quite yet. But Bear and Evans Creeks are two of the streams that have been flagged by the state, and they have passed down legal requirements for us to address specifically the fecal bacteria impairments. And just as an example, like our stormwater utility, we don't have requirements related to, say, temperature. There's a lot of streams that the temperatures are too high in the summer, but that's not because of anything coming out of our stormwater system. That's because of a bigger issue having to do with development of the landscape and removal of riparian vegetation. It's not something for the stormwater utility to address per se. So I was going to maybe go into some of the specifics about Bear Creek, but like I said, it sounds like this is a county-wide group, and I don't really know how specific to get, but I'll just say that besides Bear and Evans Creeks, we're also focused on the Issaquah Creek watershed, again, because of the fecal bacteria issues, and the White River watershed, which we sort of share the White River watershed with Pierce County. And that's also for fecal bacteria concerns, but there's also upcoming legal requirements for us to look for sources of dissolved phosphorus in water that's getting into the White River because of the pH impacts of dissolved phosphorus. And I don't want to go too far down that rabbit hole, but I'm not sure what people want to hear, but I'll just say that we sort of, more than anything else, we measure fecal bacteria, fecal indicator bacteria. We're looking for things like failing septic systems or other sometimes business practices that are contributing to that problem. And so we're measuring E. coli a lot, way more than any other parameter. We're measuring E. coli, which is the regulatory parameter for fecal bacteria in Washington State. And we've been using coli scans for years. And now we're sort of thinking about shifting to R cards. I don't know if that's something you want to talk about. So I'll stop there, but and I could talk more about the R cards as well, but I don't really know what folks want to hear. So
I think Cameron, that was a great overview, just kind of what you guys are doing. And I thought it would be interesting for people to hear that, there's a number they can call into if they have a stormwater related water quality issue, because those are some of the things that some of our volunteer monitors might see. And also, I thought it was interesting to hear that you guys have been using some of the similar bacteria monitoring techniques to us. So does anybody have any, I'll see if anyone has any specific questions for you. And if not, then I think I'm going to kind of move on in our agenda. So Brian's got a question.
So sorry, Cameron, can you put that number again? I missed it. Can you put it up in the chat or something like that?
yes, I will put it in the chat here. Sure, I did not give you the number, so I will give it to you right now.
What is the
So
number?
if folks actually would put your name in the chat, that would be helpful for me later, just to see who all was here. Awesome. All right, Mark.
Yeah, thanks, Eric. Well, I do have a question for Cameron, especially I got hooked at the beginning with the foam in the stream entree into this. We see that from time to time, and I've always wondered about it. My sense is that in many cases it's a natural phenomenon that happens, and is that true? Or when I do see foam, and people do question us about it and wonder what's going on. Are there any kind of obvious reasons for that happening that we should be thinking about?
Well, it's due to the breakdown of organic matter, natural organic matter, which certain organic matter, humic acids and so forth, are natural surfactants, and when they're breaking down, they reduce the surface tension of water and allow bubbles to form. And out say on the Enumclaw Plateau, where there's a lot of sources of organic matter in terms of crop fields where you've got organic matter breaking down, or you have dairies or animals Sometimes we can see lots of foam. One time when we had a manure lagoon failure, the foam was like mountains, several feet high of foam, but it's not, it doesn't look quite like silk foam, which has a rainbow sheen. Normally, when you just have like normal levels of natural organic matter and this natural foam in a stream, you'll tend to get like it will kind of compile or accumulate in sort of backwater areas or eddies. And they tend to be much smaller bubbles, like really tiny bubbles, not big bubbles. And you'll see like, it'll get kind of dirty. It'll have a brownish appearance rather than a rainbow appearance. So I guess, yeah, I'll stop there. Hopefully that helps. And I'm seeing some chat here. Oh, there we go. Okay, yeah. Yes, great. Good stuff. Did folks hear that?
No, yeah, Eric's on mute. Sorry, Eric, you're.
Okay.
Oh, sorry. I'm going to go ahead and share a screen here. So this is our beginning for our meeting. And so the agenda was hellos and introductions, which I think is awesome. Learned a little bit about King County Department of Natural Resources monitoring and how it interacts with us. And so the next thing that I want to touch on is Nicole has a presentation about conductivity monitoring and some research that she did. So I'm going to stop this for now. And then Nicole, do you want me to do the slides, or I can make it? I made it so you can share your screen. So if you have the presentation up as a slideshow, you can share it if you know how to do that.
Yeah, perfect. Thank you.
All right, go ahead.
Get that up, and I'll have to shrink the people. There we go. There we go. And can you guys see that okay?
Yep.
Perfect. So yeah, my name is Nicole. I did a capstone project on seeing the feasibility of using electrical conductivity as a parameter for use in the water quality monitoring program. And so I guess just a little bit of background on the project and myself. I am working towards my Bachelor of Science in Earth System Science. And I've really been passionate about freshwater and marine water. And so my main focus with my coursework has been on freshwater marine ecosystem. And I'm actually graduating soon, which I'm excited about, but that requires some capstone credit to get accomplished. And while working with the Whale Scout as an intern coordinator over the summer, when Eric was coming out to teach everybody, I guess, get them certified as water quality monitors, him and I were talking a little bit about him playing with the idea of introducing the electrical conductivity as a parameter. And I was thinking, well, that's something that I could potentially look into for him, and sort of ended up working together and making this happen. So that's just a little background on the project. So most of you, it sounds like, are very familiar with what conductivity is and why it's monitored in the stream systems. But just for those who aren't as familiar, it's by definition just a measure of the ease of electrical current to pass through water. And this fun little diagram here kind of just shows what distilled water without any dissolved ions or dissolved particles in there would not conduct electricity. But then once you add the ions, it will conduct a current and will create that energy to light up a light bulb, for instance. And so, yeah, the dissolved ions will carry a positive or negative charge, so cations and anions. Common ions that are found in the water bodies are like chloride, nitrate, sulfate, phosphate, sodium, magnesium, calcium, iron, and aluminum. Sorry, I think I need to move the bar here so I can see it a little better. So yeah, it's essentially sort of what the theme of what others have talked about so far is that pollutants getting into the water will have some particle with it, and a lot of it's these inorganic ions that will get mixed in there. And so by measuring electrical conductivity, we're able to kind of inexpensively just see if there is spikes in these levels. So it's a nice way to see what might be going on in a system if there may be impairment. So how it's measured, and sorry, I sort of threw this PowerPoint together pretty quickly, so apologies if there's a lot of wordiness on the slides, but typically, so with measuring conductivity, we will use a probe. A lot of agencies, like what Eric was talking about earlier, will have just a YSI probe that you can throw in there, but those can get pretty expensive. So it's easier to use a smaller device. The two-pronged is what I ended up looking at, but that'll essentially just release an electrical charge, and it'll go down. There's two prongs, and I'm sorry, the diagram's not showing very well, but the two prongs kind of come down like that, and it will create this electrical current in there, and essentially just be trying to measure that that flow that's going through the resistivity. And temperature can influence electrical conductivity, and so a lot of meters have the option to have it in specific conductivity, sorry. And so that is standardized at 25 degrees Celsius. So it'll adjust the unit measurement to that temperature instead of what the actual temperature of the water is currently. And this is just easier for monitoring purposes because that way it's comparable over time and space. So some examples of what influences the different levels of conductivity is the stream groundwater fed. Groundwater, typically when it goes through the earth, it'll pick up a lot of different sediments and minerals. And when it interacts with all those minerals, those have a negative charge. And so the longer it's in contact with, sorry, trying to think through all my thoughts here. So the longer it's in contact with all of these minerals, the higher the conductivity concentration will be once it's coming out into the stream system. And so some streams will end up having pretty high conductivity, but it's not necessarily from any outside influence besides just the contact it's had with the groundwater. And also runoff. And so again, kind of that note of interaction with different fertilizers or feces or things like that. There's going to be some nitrates and phosphates depending on if it's ag land or if it's running over impervious surfaces. It's going to pick up a lot of whatever is around it and bring it into these systems. And that's kind of a lot of what we're hoping to sort of keep an eye on as monitors. The type of landscape we're in, so what kind of rock and other minerals it may be going over will influence it. Like a limestone will change it versus a sedimentary rock. So those are things to keep in mind. The land use type, so agricultural, rural, urban, forested, each one we have to kind of consider what might be going on in that watershed and how that might influence the conductivity levels. And then also the proximity to marine water and the tidal influence. And so when tides go in and out, it's going to change that conductivity level depending on where that tide is. And so with all that in mind, it's very important to collect your baseline data with the conductivity meter. And this would consist of trying to do it over a good time period where you have all the different seasons that you're interacting with and different rain events and storm events and things, just to sort of see what you're looking at. And as you can see, freshwater streams have quite a wide variation in what their conductivity levels can be. So just being able to understand what your stream's typical measurements look like is very important. And that way you can then start seeing a pattern of maybe when there is some impairment and be able to make some decisions from there. So getting into the device that I used, this was an HM Digital Com 80. It was just a $26 device that I found on Amazon. Just wanted to see, hey, is this cheaper device gonna be up to the task of being able to get the right measurements, and is it gonna be accurate enough? And so I actually, through this process, ended up comparing it to the UW IES Labs $400 probe, and was getting pretty identical results, plus or minus 2 microsiemens per centimeter, which I forgot to mention before, that is the standard conductivity unit of measure. So I apologize for not catching that sooner. Yeah, so this device will also, it comes calibrated to 342 parts per million solution. And so the parts per million is just those other particles that are, it's sort of there is a relationship. I didn't do as much diving into that one as much, because I figured this meter it's kind of like a conversion that you can do with those. So I just figured focusing on the electrical conductivity would be a little bit easier to manage. It's a very small, easy to store device. I don't know if you guys can see my meter here, and I can show it at the end again, but it's very compact, very easy to travel with. You don't have to really carry it around in this big case or anything. And then the calibration solution, it's only about $13 per bottle. It's kind of a little bottle. So when you're doing the calibration, it might take up a little bit depending on how big your cup is that you're using to do the calibration. But yeah, it's easy to calibrate. I just did a quick calibration before our meeting today, and it took a few seconds. So it's not too difficult to use. And then this slide is just some examples of how conductivity has been used in the field. And so I wanted to bring up a personal story that I heard about when I had my internship with Snohomish County Surface Water Management. They had a routine monitoring of Douglas Creek, and they were finding after a rain event, the conductivity levels were just spiked way outside of the normal baseline range. And so after a little bit of investigating, they found out that the meat packing plant nearby hadn't been treating their, I guess, that wastewater that they collect from all of their processing, because they usually would gather it all up, get it processed and purified, and then spray it out into their farm fields, which would help them add nutrients for the plants to grow so they can have their own hay on site. But they were finding also elevated iron levels. And so that was just a nice way to quickly identify that there was a problem. And then they were able to do a little bit further exploration into what could be causing that. And then that's when they discovered the iron levels were way outside of range. So that was an interesting story. And then a paper that I read was titled High Resolution Stream Water Quality Assessment in Vancouver, British Columbia region, a citizen science study. And this is where they not only used conductivity, but also the other parameters that you guys are currently using in the program. And they wanted to just see how well they could utilize the data collected by citizen scientists. And so they gathered a bunch of people for a study and had them all trained and working together on these various streams. And then at the end of it, gathered up the data, did an analysis, and then compared it to the data that they've had with professionals that will go out and do this, and found that it was pretty spot on, and that the citizen scientists were collecting really good data that was usable and very helpful. So I thought that was just a fun thing to add in there. And then this graph right here is just some King County data that was provided by the King County staff member, Eve. And this is just kind of showing you that positive correlation between nitrates and specific conductivity, and how as the nitrate levels go up, you can see conductivity levels are increasing as well. And so it's just a kind of helpful correlation to understand maybe what might be going on in the water and what type of ions you might be seeing.
Nicole, just back to that prior slide.
Oh, yes, yes.
Just one clarification. Eve works for Kirkland.
Oh, yes. Okay. Sorry about that. I know Kirkland's in King County, so I always end up mixing that up. So thank you for correcting me. And then, so yeah, so some of the possibilities, and I apologize, I'm talking fast. I'm trying to not take up too much time of the meeting. So, but yeah, so possibilities with this parameter is partnering with more capstone researchers with the UW. And I was thinking, and I have more information in my paper if anyone's interested in having it emailed or looking through it. But some of the ideas I have with that partnership is having students maybe do some analysis, kind of like that Canadian research they did where they were analyzing the data and putting it into a GIS software. And I think it would be really interesting to see some students maybe use this data, find some good correlations with analysis, and also maybe even create maps in GIS since we have access to ArcGIS Pro. It would be a fun project to put a layer of impervious surfaces and compare it to some of the volunteer data in the streams and see sort of that change over time with increased impervious surface and water quality that we've been looking at. And then another idea with this parameter is some volunteer research projects. If there's anything volunteers might be interested in learning more about, or just kind of testing out some of these other cool projects you can do with electrical conductivity, then it's an easy transportable type device that it's a little less involved than the chemistry type monitoring. So you don't have to get a whole bunch of kits out and do a bunch of little chemical reactions with it. You just have to take it out, turn it on, and put it into the water for about a minute, and you get your reading. So it's one that you can just for fun sort of go out and see, maybe stream complexity, which is an experiment that I touch on in the paper as well. So yeah, again, if you guys are interested in hearing a little bit more about the details of some of the different projects that are possible, let me know and I can send you that. And any questions?
It sounds like a no.
Well, actually, I'm sorry, I'm late coming in. I do have a question.
Okay, yeah.
It's Mark Phillips, Nicole.
Mm-hmm.
I was just curious, we do tests for hardness as part of the array of tests that we do, most of us, many of us. I'm wondering, there must be a relationship between conductivity and hardness. Do you have any sense about that, or?
I think I recalled reading a little bit on that being possible, like a possibility, but I don't know. I didn't get too much into that. I know that fecal coliform there might be, but it's not a direct correlation. It's just mainly because of the nitrates and phosphates that can be carried in feces. And so if you're seeing some elevated levels of conductivity, maybe you can test for some of the fecal coliform and see if there might be some contamination with that. But yeah, I'd have to do a little bit more digging. I'm sorry. I'm a little rusty on that one.
Boy, it sure seems like an easy test to do if we wanted to add that.
Yeah, and I had a lot of fun with it too myself. I found myself going out and just collecting data that wasn't going to necessarily use, but just to kind of see how things have changed with different streams of interest. So
yeah, well,
and if I can chime in with Mark's comment,
yeah.
I believe that conductivity would also include things that other than hardness that causes conducting. But so Nicole, my question is, does micro Siemens, the King County I believe measures it by micro ohms? Do you know if there's, is that the same thing, or?
It's the US units, I believe. I think the rest of the world uses the micro Siemens, but yeah, I've seen that's typically like the US, and I believe there is probably a conversion for that one. I'm just, again, I don't have it readily available,
I
but
think they're the same. They're basically the numeric value will be the same. It's a 1-to-1 comparison. And
Oh,
I
that's good.
agree that hardness refers specifically to calcium and magnesium ions, and it's measured in different units than conductivity. And conductivity is going to take into account any ions, because all of the ions are conducting electricity, not just calcium and magnesium. But in some ways there is a relation because they're both related to the ions. Just one's more specific, one's just calcium and magnesium.
thank you.
I had a question. Wait, can you hear me, sir? I'm on a different screen. Can you hear me?
Yeah.
Okay. You said that it's temperature related, and if it's typically around 25 C, usually when there's the greatest runoff and the greatest potential for pollutants, it's when the temperatures are colder and they're more like, 10 to 15. So how does that affect?
Yeah, so sorry, I kind of blew through a lot of this really
No, I know
fast, so
that,
I
but
apologize.
trying to
So
condense in 5 minutes, so.
so what that was is it's just a specific conductivity. They standardize it, so it'll adjust your conductivity measurement to as if it was 25 degrees. So whether the water is like 15 or 20, it's gonna still just standardize it to that 25 degrees and adjust the units accordingly, or like the measurement you get accordingly.
Sure, okay, all right. Fascinating.
Yeah.
Nicole,
Yeah, I
do you
learned a
know-
lot through this, and I apologize for fumbling on some of this
Don't.
concepts a little bit.
You're
But
doing a
So
ton
Nicole,
of stuff.
Nicole, do you need to do a conversion then when you're at a different temperature?
no, the device will do that itself
Okay,
if you're
okay.
if you're measuring in specific conductivity,
Okay.
which it will show you the different units, and that can be probably a part of the training, is making sure people know which one to be in to get what information they want out of it.
Hey, Nicole, I have a question.
Okay. Hey, Nicole, you could also commit sharing your screen, I think.
Oh, yeah. There
Yeah,
we
I was just going to ask, what is best practice for establishing the baseline? Is there a good methodology or like frequency you need to test?
I think it varies. I know mostly they have just for volunteer monitoring is once a month, but I think if you're going to try to do baseline data, I would try to be as consistent as possible. So maybe once a week or something like that. Because then, yeah, you want to also see what it's looking like just during different events as well. So rain events versus drought, because yeah, I noticed even just with these last few seasons we've had extreme drier than normal conditions, and then we've had wetter than normal conditions. And so yeah, it's it's kind of a challenge to try to, I don't know if I've actually looked into the standard for collecting the baseline. And again, that might be something Eric and I can kind of fine tune together going forward. But
And sorry to just keep chiming in, but I do know that King County looks like I was just checking their website. They do post their conductivity readings per month, so that could give you a baseline of what you think your stream should be. So anything outside those baselines, you could use as an abnormal reading.
thank you. Yeah, that's what I was thinking, once a month, because I know that that's usually what the agencies will do. But if you're feeling up to more frequent measurements, more data doesn't hurt. So
Got it. Thank you.
Awesome. Well, that was fantastic, Nicole. Thanks for sharing that.
of course. Yeah, thank you.
Okay, I got a couple of other items for us to go through. Hopefully people are able to stick with us a little bit. Let's see. And maybe somebody can mute. I'm getting some weird background noises there. Okay, so the next thing we're going to talk about is R cards a little bit. And then we're going to also, I'm just going to briefly touch on our kind of proposed training schedule. So when we talked about conductivity, our cards is something that we've been moving to for a couple different reasons. They're sort of easier to deal with, easier to store, easier to read, and we've had quality control issues with ColoScan EasyGel, so we're kind of moving away from that. There's a variety of different cards you can get, and so we have been evaluating some that were E. coli and other coliform. That's what's used by Global Water Watch. And really the only reason to get the other coliform is just so if you have a blank, you actually know that you put the sample on there. But I think we're going to probably move to just the E. coli cards because that's more what's of concern to us. And it's easier to count. So some of the, there's some different ways you can sample it, and I'll show you. I made a little short video that shows how the different methods are that you can collect it. So I'm going to show that in a minute here. Because some of our volunteers have tried this and they've had some issues. So I'm going to stop this share. And I'm going to share something else. Which hopefully, can you guys see this video?
Yes. Well, I see you.
Okay, it'll be a video momentarily. Moved to the R card recently from the ColoScan EasyGel technique. Oops, let me start. Hi, this is Eric Admin of the Sno-King Watershed Council, and I'm here to talk to you today about how to use the R card for collecting water samples to test for bacteria. So we've moved to the R card recently from the ColoScan EasyGel technique, and I'll show you the materials that we're going to use and a couple different ways that you can collect and plate your samples. So our cards come in a variety of sizes and types. So we have a couple different types here. We have the R card ECCA, and this is designed for up to a 3 ml sample. So you can see this is a larger card. And then we have the R card ECC, which stands for E. coli and other coliform, in the 1 ml sample size. So you can do a maximum of a 1 milliliter sample with this one. Other materials that come with the R cards are, they come with a sterile container that you can collect samples in if you choose to. And they also come with pipettes. Typically we order the 1 milliliter pipette, but in some cases we like to use the 3 milliliter pipette, although we've discovered it's easiest to actually collect a 2 milliliter sample with this. Now I'm going to demonstrate a few different ways you can collect your sample, and then I'll demonstrate the process of plating onto the R card. So in terms of collecting your sample, there's 3 different ways. One is you can pipette directly from the stream. Another method is that you can use the sample container provided, the sterile sample container, which can be sterilized and reused, so you don't have to toss this after you've used it. And then some programs use a dipper, and so they collect their sample with a dipper, and then they pipette out of the dipper. So I'm going to demonstrate collecting a sample with each of these methods, and then how we plate the sample onto the R card, so you can see how that goes. So with the dipper, this is something that you're going to want to rinse out 2 to 3 times with stream water. And collect your sample. And this is something that some programs like because you can use this without getting into the stream. So I'm going to collect this sample, and I'm just going to set it somewhere stable. You could have a helper who holds it for you, or you can just put it somewhere where it's not going to tip over so that you can pipette your sample out of that. So then what I like to do is I like to get my pipette ready. So for this purpose, we'll do a 3 milliliter pipette, and we'll do the 3 milliliter R card. Now, if you watch the Roth training videos, they recommend that they either use sterile forceps or sterile gloves for opening this. What we found in practice in the field is that that can be a bit difficult for people. So I think for our purposes, or if you just have dry, clean hands and you're careful not to stick your fingers right in the principal area of the R card flap, then you won't have a problem. So I've got my pipette opened. I'm going to get my pipette out, ready to collect my sample. So I've got my clean pipette. And then I'm going to take my R card and I'm going to carefully open it up and just hold the flap back. And now I'm going to collect a 2 milliliter sample. I could do up to a 3 milliliter sample. And I'm just pipetting directly out of this sample jar here. So I've got a 2 milliliter sample. And I'm just going to place this on the center of the card. And keep it centered. And that's the trick with this technique, is keeping your sample centered. So once I've collected the sample, I'm going to let the lid drop back, the flap, and you can see how it starts to spread out. And the key at this point is just to hold it approximately level. Luckily, this is a card that's designed for a 3 milliliter sample, and we're just collecting 2 milliliters. So it shouldn't spread too far. It shouldn't spread beyond the edges of the card. The other issue that people encounter sometimes when they're collecting on our card is that if you tip your card sideways at this point, some of your sample can run off. And so at that point, you just have to repeat your sample. So the key is whether you hold it, or some people put it on a clipboard and hold the clipboard level, or you might have a partner help you hold it. You just want to let it sit level until, you know, maybe 30 seconds to a minute have passed. And then essentially it's spread out as far as it's going to spread out. So you can just set it on a level surface and you're ready to collect your next sample. So I could do up to 3 samples with the same pipette. For our purposes, I'm going to demonstrate collecting a sample with a 1 milliliter pipette. So I'm going to put this one away and I'm going to use a different sample. The next thing I'm going to demonstrate is collecting the sample with the container, the sterile container that comes with the R card. So in this case, and in every case, remember, if I'm standing in the stream, I want to collect the sample upstream of myself, or I may not even have to get into the stream at all. So in this case, I'm getting into the stream and I'm collecting the sample in my sterile container. And if I wanted to carry this sample back somewhere, like say to my vehicle or another location, I could put a cap on it. And I could then pipette out of this sample at a different location. So for your site, that may make it easier. In this case, I'm just going to put it on my box here that has my water monitoring equipment. But I mentioned clean, dry hands. So I'm going to dry off my hands so I'm not getting any additional bacteria or contaminants on the card. I could use hand sanitizer if I wanted to be absolutely careful. And now I'm going to get my 1 milliliter pipette out. I'm going to get my R card ready to collect a sample. So I'm just going to carefully hold this back. And I'm going to draw a 1 milliliter sample. And again, I'm just going to carefully place my 1 milliliter sample in the center of the card until the whole sample is there. Let the flap drop back. And then I'm just going to watch that sample and let it gradually spread out. And you can see that if I tip it, it does go in certain directions. So if I don't hold it level as it spreads out, it's possible it could go beyond the edge of the card. But at a certain point, it just quits spreading out. And you're safe to collect another sample and plate another sample. So for the last sample, what we're going to do is we're going to demonstrate pipetting directly from the creek and then putting it on your R card. So this one I think is fairly safe right now. It doesn't seem to be traveling too much. So I can put this on a flat surface. Just let it finish kind of gelling, which just takes a couple minutes. So now in this case, I could have a partner holding this card, or I could be holding it myself. In this case, I'm going to get it ready to go so that when I collect my sample, I'm ready to put it right onto the R card. So I'm not going to get into the creek. I'm going to just draw my sample, making sure I'm not on the bottom of the creek. Okay, so I've collected my 1 ml sample. Again, I'm just going to pipette, plate it directly in the center of the R card. You can see how it kind of stays together in one bubble. Then release the flap. And again, I'll just wait for it to spread out. And then once it is finished spreading out and appears to be stable, I can set it down. And then we'll be ready to take these to where we're going to incubate them and place them in our incubator. So that's it for now. The next segment, I will show how we incubate the R cards. Okay. Any questions, comments, constructive criticism, etc. on the R card?
Okay, I'm unclear. So you can put the 3 milliliters, the 2, and or the 1. Does the card, are they specific to the size of the sample that you're giving?
There's 2 different sizes. One is made for only a 1 milliliter sample, and it's a smaller card.
Okay.
And so, like, I've got some sitting here. This is the size of a 1 milliliter. This is the size of a 3 milliliter card.
Okay,
It's a
okay, that's
bigger
because
card
it's
designed for-
otherwise I thought the counting would be off. And I'm going to have to go, and I don't know how to exit here without being rude. So
You can just leave.
I can just leave. Okay, when
Yeah,
I figure
just
that
click-
out.
Just click
It's
leave.
nice meeting you all. I'll be seeing you again.
Yeah, I think we're close to wrapping up here, but thanks, Paula.
Okay, thank you.
Okay, I think Anna had something that, and I know Anna's been using the R cards.
Yeah, a couple of things. I mean, the reason to use the 3 mil is because the sample size is so small. 1 mil, even 3 mil is really small when you consider that a lot of people who sample for bacteria, they're using like 100 mil or larger bottle. So they're probably increasing the size of the R card just to get, the chance to get more bacteria. And I just did a test where I did an R card, and I also took a sample to a lab, and my R card found no bacteria. The lab found it was most probable number, so it was 50 per 100 mil. So you're not going to catch everything when you're taking such a small sample. That's one thing to remember. The other thing is, I find I use the 1 mil cards. I got a mechanical pipette, which just makes it so easy. And we do our pipetting. We take our samples in a vial and put them on ice and bring them back. And because we're visiting multiple sites, we can't plate them and incubate them right away. So we have to plate them all at the end. Once we get back to the office. And I really do find that if they're at all not flat, water will come out of the edge. It'll slip out if you don't have them flat. So I don't, you were like showing that, and I was like amazed that you were able to keep it all on the card. But the other thing is, I'm a little concerned by the way you were doing it. When you lift that acetate sheet, are you touching the underside of the sheet? Because that would introduce bacteria on your hand to the sample if you're getting anything on the underneath side of the sheet.
I think to be, completely, like, if this was if it is possible that would be the case, but I think that if I were to do that, I am touching the very edge of the sheet, where
True.
the sample
Which
doesn't
typically is not where the bacteria is.
Yeah, so the sample doesn't go all the way to the edge of the sheet where my hand comes in contact with it. And so if
Yeah.
I did have a wet hand, and I could introduce some bacteria to that, but I think because I'm trying to dry off my hand before I do the sheet, I don't think that's an issue, but we may discover that in fact, I mean, the best practice is probably to adhere to exactly what's put forth in the manufacturers, which is either sterile gloves or a sterile forceps to make sure you're not any chance of using anything else. But I think this was just for practical purposes. I don't think it's a big issue, but if we discover it's an issue, then we might want to make sure that people follow that practice.
The other thing is, if you're going to use the vials, I mean, you use them once and then you got to throw them away or find a way to sterilize them, which is not easy with plastic bottles. I've been reusing them and cleaning them in bleach and DI water to reuse them for our purposes, but that would never really fly. And so we're thinking about switching to glass vials, which we can sterilize and take out every week. So we're not, I just hate the idea of throwing so much plastic away. So we're trying to figure out a way to reduce our plastic use.
Yeah, well, I guess that would be a good question too. It would be interesting to experiment and say, because I would think that just general washing with hot water, soap, and air drying is probably going to kill bacteria, but it's not, it's not going to sterilize it for immediate reuse. But I would say that it's probably going to kill most bacteria. But I guess again, we could kind of experiment and see if that seems to be introducing any element.
We've been having pretty good success with just a bleach solution, but it's just a mild bleach solution, and then I do a final rinse in DI water, and then when I'm reusing the vials, I'll rinse them out 3 times with the sample water.
Yeah.
So it works okay, but like ecology would never accept the data, and I'm trying to find ways where we can have our data potentially more acceptable to ecology.
Sure. And I don't know if Jeannie or Cameron, I don't know if you guys have any comment on that from your standpoint.
I could say I have never sterilized one of the small bottles, but Cameron and I sort of pioneered using it's called a Wabi Baby, WABI baby. It's a baby bottle sterilizer, and what we sterilize with that is as what Anna uses. We also use Sartorius mechanical pipettes, which are great because they're adjustable volume. And we also, what we use the Wabi Baby bottle sterilizer for is to sterilize the plastic pipette tips. So we're not throwing tips away. We'll put them in the corner of our workroom for a couple of weeks in a box. And then every now and then we run them through the Wabi Baby sterilizer. And so I just wonder if that could be something to sterilize these little plastic vials with, but I don't know. And we are not submitting our data to ecology. We use our card or our ColiScan EasyGel data as just indicative of problems. If we really want lab accredited data, we'll submit samples to King County Environmental Lab to get E. coli results.
And I will just say that, judicious use of field blanks is always a good thing. With regard to the pipette tips that we are sterilizing using the baby bottle sterilizer, we've run many field blanks, and we've never had anything growing on those plates. And we're actually going to start doing the same thing with the little plastic vials. The same thing with the bare hands versus gloves. Just doing so many blanks, dozens if not hundreds of blanks, it's very hard to contaminate your sample with your bare hands. I mean, unless you're just being really careless with where your hands go, you don't have E. coli just coming off your hands and going onto your Collie scan plate or what have you. But again, I know you still want to have a straight face, and so I guess it depends on what you're trying to do with the data. The one other thing I'll say is going back to Eric, like constructive criticism, and also, yeah, Anna touched on this. Anna, right? Yeah, we also, it's using only 1 or 2 mils for a sample. If you're trying to detect trends in a stream over time, that's a problem. Even 5 mils for a Collie scan is not very much, but it's better than 1 or 2 mils. If you're going to go out on a day like today to Bear Creek, it hasn't rained in a while, it's the middle of the winter, you're going to have low levels of E. coli in the stream, and you're not going to detect anything with your R card. The suggestion I would make is it might be, because there are benefits to the R card, is maybe doing more than 1 sample. Smaller volume, you'll have two samples. And I think, Alabama Water Watch used to do, I think, 3 Collie scans for their monthly.
Yeah.
I don't really know, but the last thing I'll say is that we're having the same issues with the Collie scans in terms of the quality control. But over the years, the data that we get, we've done a lot of, maybe hundreds of side-by-sides where we'll submit a sample to the lab, the official lab, using the standard method, and we'll pipette out of the bottle and do our Collie scan, and the results they line up very, very well. So moving to the R cards, we were a little bit worried. Well, the Collie scans do give good data. What about the R cards? And in summary, we've done about 45 tests where we compare R card, Collie scan, and the lab method. And what we find is basically the R cards do a better job when you have high levels of E. coli. So like over 200, 300 CFUs per 100 mils and up on into the thousands. R card is going to give you a much better result, much closer to the lab result. The Collie scans underestimate at the high levels. But once you get down to the lower levels, like under 100 CFUs per 100 mils, the Collie scans are actually better, again, because you're using a greater volume and you're able to detect those lower levels. You're not going to have as many non-detects. So anyways, that's kind of a lot, but so there's definitely pluses and minuses depending on what you're doing.
Cool.
That's good. Thank you. And Brian, did you have a question?
Oh, Cameron did a great job of answering one of them, which was, my thought was that the R cards will only detect either coliform or E. coli, so bacteria on your hand may not have a huge influence on it. So that's something I've kind of gone with, and we do ours in triplicate, which is it seems that we've never had a failure of no bacteria in our creeks. Maybe that's a bad thing, I don't know. But we've had some good success with the R cards. I had a question about the incubation time. Am I nuts, or does it seem like the incubation time is really not that important? Because I've had R cards here. I've got some in my thing, and they just don't change. You incubate them for 48 hours, and you read your count. I can come back 3 weeks later, and I'm reading the same count. So, I mean, is incubation time really a big deal? I mean, I'd like to hear the expert opinion on that.
I'll just say from my experience that I incubate it typically about 24 hours, and then I will read it. But I found that it seems like it kind of shows its count better if you wait like an additional day. So you take it out of the incubator after 24 hours, and then the next day,
yeah, I do the same thing.
Maybe easier to see, but your numbers haven't changed. It's just a little bit easier to see the colors.
I agree, Eric. Yeah.
I know that with the Collie scans, at 24 hours, there's interpretation issues with the Collie scans. At 24 hours, you might have some small pinpricks, which are going to end up growing on you, or growing over the next 24 hours. And so I mean, I guess you just need to standardize what you're doing. But I know with the collie scans that after 48 hours, they said that anything that starts showing up after 48 hours of incubation, it could be some non-target bacteria, because there's, with the gel in the collie scan, there's inhibitors that are inhibiting the growth of other bacteria that you don't want to grow. After 48 hours, they might start overcoming that. So with the collie scans, I would say try not to wait over 48 hours. But with the R cards, I mean, we're still learning about them. And just generally my experience, 24 hours, you can read it, and there's not as much ambiguity as like, oh, should I count this here or not? Much easier with the R cards. But whether that whole inhibition issue is present with the R cards, nice thing is that Jonathan Roth loves to talk on the phone. So if you just call up, you just call him up and ask him that, he's the real expert.
Yeah, I've experienced a nice, long, informative conversation with Jonathan Roth myself. Jeannie, you have a hand up.
Yeah, and actually this is something that Cameron can probably speak to a lot better than I can, but something Cameron said, I wanted to clarify, and Cameron, you might want to follow up. Cameron said that our cards, collie scans, and our accredited lab results line up very well. Now, that doesn't mean that the absolute values of our cards, collie scans, and accredited lab results are the same. I believe what Cameron meant is that a high collie scan result is equivalent to a high lab result, not in an absolute term though, just in if you bin all your different.
Well, that's true of the collie scans, but actually the R cards actually give similar numeric results. I mean, they're good, but
excellent.
We're still learning, so.
All right, well, I got just a couple more things to close us out here. I think this was excellent discussion on the R cards. I'm just going to share. Hopefully I'm on the right screen. Okay, so sample collection, we just talked about that. Then incubation, you just place them in the incubator. They say 35 plus or minus 0.5, and they say that if you're just doing E. coli, you can go to a higher temperature. And then when you read the results, this is an old card I took a picture of, but basically you're just counting the blue dots, and it's even easier. So just briefly to touch on, and there's that picture of Stacy that I promised you, our 2023 training plan. So we have a bunch of stuff that's not even scheduled yet. We typically end up doing various training activities with some of our particular partners. So that could be with Puget Soundkeeper and UTB, could be with Nature Vision, could be with the Stream Keepers. But right now we definitely have a training plan for March 4th for water chemistry and bacteria monitoring. So that's probably going to be, I think we're going to go back to an in-person model. So if people want to do in-person classroom and then a field in conjunction with that, then sometime in the late spring, probably going to do a stream flow and habitat monitoring class. Summertime, we're going to be covering global water watch stream biomonitoring and benthic biotic index of benthic invertebrates. I'm getting my acronym mixed up, but BIBI quantitative stream bug assessment. This fall, probably another water chemistry monitoring class. So I'm going to stop sharing at this point and just ask if anybody has any questions about that. So Anna.
If you're going to do that March 4th in person, where's it going to take place at?
Right now, I'm kind of lining up people. I wasn't sure if I was going to have, I don't know if Stream Keepers and Forest Park's going to have a bunch of people. I have a couple of, a new project that we're taking on is there's a Girl Scout troop in the Cottage Lake area that's interested in getting involved in water monitoring. And I also have some other new people who've requested training, and I may have some monitors who are coming back for refresher training who've been out of it. So I haven't got the exact location yet. It's going to I'm going to try to be flexible and sort of go where the most people are. Do you think you might have some demand for that class?
Well, since it's on a Saturday, I could offer LUC kids. I will not be, I'll still be away actually that day, but some of the UTB kids might want to come if it's not too far away.
Sure. Yeah. As soon as we figure out the location, I'll let you know.
Okay. Cool.
Brian, do you know if anyone in Stream Keepers is going to be wanting training?
At this point, I don't. I haven't heard from anybody.
Okay. Okay, and then Kelly said she would be interested. And I don't know if Kelly, if your audio is on or not, before we couldn't get your audio, but I saw your chat that you'd be interested. Are you, I'm trying to remember where you're located.
So I think I got my audio fixed now. I'm with the McSorley group down in Saltwater State Park. And so I partner with Bob, and we have a new guy that started joining us. His name's Jamie, and we go out twice a month and we do the water chemistry and the bacteria down there at McSorley. And Bob has been doing that for like 3 years, and I've been joining him for over a year now. And so I took a lot of your training last like winter when you were doing it via Zoom.
Well, I think what I'll do is I'll put it out there and see. I just picked that date because some of my fellow trainers would be available for a larger group on that date. But I can also, you know, if it turns out that we've got smaller groups here and there geographically distributed, we could schedule some practical sessions around the area too. I just have to work around the fact that I'm going to be driving a rickshaw across India with Stacy for the month of April. But that's another story.
Sounds like fun.
Yeah.
Hey, Eric, are you going to post all those dates on the Water Watch or on your Sno-King watershed website there?
I will.
Okay.
Yep. Okay, awesome. Anything else from anybody? Any other questions, comments, general good of the order?
I did want to just mention I put a PDF of that paper that I wrote in the chat if anybody's interested.
So Eric, the next meeting is you said in a few months from now?
Yeah, we don't typically have, we have maybe 2 or 3 of these monitor meetings a year.
Okay. And you're going to be gone in April, is that right?
I'm going to be gone in April.
I might call you up here in the next few weeks to chat about some stuff, but we don't need to do it now. But thank you so much for inviting us.
Yeah, it was great to have you guys here. I think it was really beneficial to us too.
Yeah, thank you, King County Stormwater, for coming, and thank you, Nicole, for the talk. That was great.
Yeah, thanks, Nicole.
Yeah, of course. Thanks for bearing with me. I haven't presented in a while, so my apologies on any of the speediness or missing concepts, but
You did fine.
thank you.
All right. Well,
Thanks, everybody.
See
Ciao.
you later.
Thank you. Happy New Year.
Thanks, Eric.
You too.
Thank you.